Important point regarding the potential energy. As we have seen previously, the work done in assembling the system is equal to the potential energy of the system, or done in disassembling the system will be negative of work done in assembling the system, that is negative of potential energy of the system. Thus we can write W assembling equals to U, that is potential energy of system, and W disassembly equals to minus of U, that is negative of potential energy of the system. And we know that potential energy of a system is defined as delta W equals to delta W assembling equals to delta W delta U infinitive to P, or delta W infinitive to P assembling equals to delta U infinitive to P, or UP minus U infinitive equal to UP, and delta WP to infinitive, that is disassembling, equal to my delta U P to infinitive, or equals to U infinitive minus UP, or equals to minus UP. A charge Q is uniformly distributed over a spherical volume of radius r meter. A. Obtain an expression for the energy of the system. B. What will be the corresponding expression for the energy needed to completely disassemble the planet Earth against the gravitational pull amongst its constituent particles. Assume the Earth to be a sphere of uniform mass density. Calculate this. Calculate this energy. Given the product of mass and the radius of the Earth to be 2.5 into 10 to the power minus 31 kilogram meter, that is R into G is R into M into R is given, and G equal to 10 meter per second square. See, if the same charge of Q as in part A above is given to a spherical conductor of same radius r, what will be the energy of the system? Solution. A case of solid sphere of charge, hence energy of the system equals to self energy of the system equal to potential energy of the system, which we have calculated in theory, 3q square by 20 pi epsilon naught r. B. In the case of electrostatic and gravitational for external point or a spherically distribution, we have respectively V electrical, that is potential electrical, equal to 1 by 4 pi epsilon naught q by r, and V gravitational is equal to minus G m by r, so that we compare each other and we get 1 by 4 pi epsilon naught equivalent to minus of G and q equivalent to m. And hence gravitational potential energy of a spherical mass will be Ug equal to 3 by 5 1 by 4 pi epsilon naught q square by r. Comparing, it is for electrical, so we have to put in place of 1 by 4 pi epsilon naught as minus G, and at q in place of q as a m. So we have 3 by 5, here this value is transformed, replaced by minus G, and q is replaced by m. So the 3 by 5 minus G into m square by r, or equals to minus 3 by 5 G m square by r, or minus 3 by 5 Gm by r into r m. Gm is equal to G into r square. Here, since G equal to Gm by r square, so Gm into G into r square equals to minus 3 by 5 G into r square by r into m. R will cancel, so minus 3 by G m into r. So this will be the gravitational potential energy of Earth or any spherical planet will be given by this formula, where G will be the acceleration due to gravity of that planet, or in the case of Earth it is the acceleration due to gravity. Hence W dissembling equals to minus of U in Ug or equals to 3 by 5 Gm into R or 3 by 5 into 10 into 2.5 into 10 to the power 31 equals to 1.5 into 10 to the power 32 joule answer. See, this is the case of hollow sphere and hence U equal to Q square by 8 pi epsilon naught R. We have calculated the potential energy of hollow sphere which is equal to Q square by 8 pi epsilon naught R, or this can be also written as 1 by 4 pi epsilon naught Q square by R. Now in the case of gravitation, this will be changed by minus G and Q will be replaced by M. So similarly for the gravitation, Ug will be equals to 1 by 2. This value is equivalent to minus G and Q is equivalent to M. So minus G into M square by R equals to minus G M square by 2R, or equals to minus Gm into M by 2R, or putting value of Gm, the minus G into R square M by 2R, R cancel. So minus half G into M into R. Hence W dissembling equals to minus of Ug, that is gravitational potential, negative of gravitational potential energy, equals to 1 by 2 G into M into R. So this much energy is required to disassemble the earth into its constituent particles. Next, report important points in charged spherical surfaces. 1. For the electric potential due to a conducting sphere or cell, we should keep in mind first, electric potential on the surface and at any point inside the sphere is V surface equal to V inside equal to 1 by 4 pi epsilon naught Q by R, where it is shown. And second point, electric potential at any point outside the spheres will be V out equal to 1 by 4 pi epsilon naught Q by R. This is the case for outside point, and this is true for only conducting surface. Conducting a sphere or cell, both for both it is true, because in a conducting sphere, when we give the charge, it comes on the surface of the sphere. Next, concentric spherical cell with charge is shown. Find the electric potential at the surface of a sphere A, B and C. एक मिनट बाद अब solution. Here it is the situation of a spherical surface is shown. Now potential on the surface of A equals to 1 by 4 pi epsilon naught QA by RA plus 1 by 4 pi epsilon naught QB by RB. Potential at A. Potential on the surface of A equal to 1 by 4 pi epsilon naught QA by RA. This is due to this sphere, and 1 by 4 pi epsilon naught QB by RB because this sphere is inside this sphere, so potential will be for this second sphere, and plus 1 by 4 pi epsilon naught QC by RC because again this sphere is inside this sphere, so QC by RC. Hence potential at surface A will be VA equal to 1 by 4 pi epsilon naught QA by RA plus QB by RB plus QC by RC. Now potential at the surface of B equals to 1 by 4 pi epsilon naught QA by RB plus 1 by 4 pi epsilon naught uh, QB by RB plus 1 by 4 pi epsilon naught QC by RC. Here in this represent the outside point of a sphere A, so it will be 1 by 4 pi epsilon naught QA by RB, because distance for this sphere will be have as a point charge for the point at point on the surface of B. So this distance from this point charge and at point on the this surface is equal to RB. So we have written here RB, and for this will be the case of potential on the surface of a conducting sphere. So 1 by 4 pi epsilon QB by RB, and this is the case that potential due to inside point of a conducting sphere. So 1 by 4 pi epsilon naught QC by RC, or VB equals to 1 by 4 pi epsilon naught under bracket QA by RB plus QB by RB plus QC by RC. Now potential at surface of C. So at surface of C, both this sphere will behave as a point charge, point sphere, and this or sphere will also behave as a this point for point sphere. So will be 1 by 4 pi epsilon naught QA by RC plus 1 by 4 pi epsilon naught QB by RC and plus 1 by 4 pi epsilon naught QC by RC. Hence BC will be equal to 1 by 4 pi epsilon naught QA by RC plus QB by RC plus QC by RC. Next, three concentric spherical metallic sphere A, B and C of radius A, B and C, A is less than B, L is less than C, have surface charge densities sigma, minus sigma and sigma respectively. A, find the potential of the three cells A, B, C. B, B, if the cell A and C are at the same potential, obtain the relation between A, B and C. Here situation is shown. This is the spherical cell or a spherical metallic sphere of radius A, this or cell of radius A, and it is a metallic sphere of radius B, and this is the metallic sphere of radius C, and it is given the surface charge density of this metallic sphere is sigma, and surface charge density on this sphere is minus sigma, and surface charge density is sigma. So we can calculate the charge on QA, sigma into 4 pi A square. Charge on QB will be minus of sigma into 4 pi V square, and charge on QC will be sigma into 4 pi C square. Now potential of cell A equal to VA. Say then VA will be equal to 1 by 4 pi epsilon naught QA by RA and plus QB by RB due to second sphere, because it is inside point for the second sphere, so radius will be for RB, and plus QC by RC because it is also an inside point of third sphere, so QC by RC. So we have 1 by 4 pi epsilon naught sigma 4 pi A square by A plus minus sigma 4 pi B square by B plus sigma 4 pi C square by C equals to 1 by epsilon naught sigma A minus sigma B plus sigma C, or sigma by epsilon naught into A minus B plus C. Answer. Now for B, let potential of cell B is VB, then VB will be equal to 1 by 4 pi epsilon naught QA by RB due to the innermost sphere A. So distance will be RB because for it is the outside point, and plus QB by RB because it is on the surface of second on sphere B, and QC by RC because it is the inside point for a sphere C. So 1 by 4 pi epsilon naught sigma into 4 pi a square by B plus minus of sigma into 4 pi B square by B plus sigma into 4 pi C square by C equals to 1 by epsilon naught under bracket sigma into A square by B minus sigma B plus sigma C, taking sigma out of bracket, sigma by epsilon naught equals to A square by B minus of B plus C. This will be the answer. Next, potential of cell C. Vc will be equal to 1 by 4 pi epsilon naught Qa by Rc because a sphere A point on a sphere C is the outside point. Similarly, for a sphere B, the point on C is the outside point for a sphere B. So QB by RC and plus QC by RC because it is on the surface of sphere C. So equals to 1 by 4 pi epsilon naught sigma into 4 pi A square by C plus minus sigma into 4 pi B square by C plus sigma into 4 pi C square by C equals to 1 by epsilon naught under bracket sigma into A square by C minus sigma B square by C plus sigma into C, taking common sigma by epsilon naught equals to A square by C minus B square by C plus C. Now B, according to problem, V is given equal to Vc. So equating these two values, sigma by epsilon naught minus A plus B plus C equals to sigma by epsilon naught A square by C minus B square by C plus C. This implies A minus B plus C equal to A square minus B square by C plus C. This implies A minus B, because C will cancel, equal to A minus B into A plus B by C. Now A minus B will cancel, so C equals to A plus B, answer.